Hello friends, Eli Hibbett here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in.
Hey, how is everybody feeling today? I am your host, Eli Hibbett, back at you again with another edition of the Pwn Your Homework Physics Series podcast. And today we have for you episode number 72, the right-hand rule, where we'll be getting into all things right hand. So first, let's take a look up into the sky at the moon. Tonight we are 61% illumination, first quarter moon, and we are 5 days away from the full moon and 20 days away from the next new moon. And I think we're going to be able to see it loud and clear here on gorgeous Long Island, New York. Blue skies today, and I was actually able to catch the moon through all of New York State a couple of nights ago. We were driving back from a thing, and yesterday as well, very clear. Looked great. It's great to be able to see something like that in the sky, you know, kind of whenever you want at night. It's not lost on me, at least. So that's what's going on celestially, at least remotely. And so let's dig into the right-hand rule. So last time we did the cross product, and we kind of went through some steps as to how that works. But one thing that you have to know is, so A cross B equals C. Vector A crossed with vector B yields vector C. And that vector always points perpendicular to vectors A and B. And so if you have, you know, like an XYZ axis, if you have vector X cross with vector Y, it'll point in the direction of vector Z. But you have two directions that are perpendicular to your two vectors at any time. You could be pointing up or down, so to speak. And so in order to figure out which direction it is, we use the right-hand rule. And so what you can do, if you hold your hand out, your right hand, of course, palm out, flat hand, and you point your fingers in the direction of vector A and curl your fingers towards vector B, your thumb will always point in the direction of vector C. So, you know, if you're doing a multiple choice question where you have to do cross products, and you can actually eliminate quite a few answers just by knowing that little bit of information. It's also how your X, Y, and Z coordinate axes have to be labeled. They follow the right-hand rule. If you point your fingers in the direction of X, curl them towards Y, your thumb points in the direction of Z. I used to make that mistake a lot when I was in college. Well, at least when I was starting out. You know, I would kind of start drawing my 3D axis and kind of just label them however I wanted. And I would have an issue with my sign of in the Y axis. I'd always point in the wrong direction. And once I learned, you know, that right-hand rule, everything became very clear. Because there's different ways to label it. You know, they're all perpendicular, but they have to be labeled just so in order to get that axis the way you want it. One other thing I think that we can mention here is IJK. I hat points in the direction of the x-axis, J hat in the direction of the y-axis, and K hat in the direction of the z-axis. So very similar, and they're unit vectors of length 1. And if you cross I hat cross J hat equals K hat. Follows the rule, right? X cross Y is equal to Z. If you point our fingers in the direction of I hat and curl our fingers towards J hat, which is in the Y direction, our thumb should point in the direction of the Z axis, which is also lined up with our K hat. Now, so what happens if you have J hat cross K hat? What do you get? If we take J hat, point our fingers with J, curl our fingers towards the Z axis, our thumb will be pointing in the direction of I hat. So J cross K is I, and likewise, K cross I is J. If you take your Z-axis and curl your fingers towards the X, your thumb points in the direction of the Y-axis. A little trick. So what we used to do in electromagnetism, we used to write IJK, IJK, or you can do XYZ, XYZ. But IJK for vectors is very useful. If you go from left to right, it's always positive. And if you go from right to left, it's always negative. So IJK, IJK, I cross J is K, positive. J cross K is I, positive. K cross I is J, positive. Now if we go the other way, J cross I equals K, but I'm going from right to the left, so it's J cross I is equal to minus K. I cross K is minus J, and K cross J is minus I. So this is a really, great generalization, and it all comes from the right-hand rule. You can prove it all if you have a right hand. I guess we're discriminating against people without right hands. But you guys too, just, think of it in your head. One thing I did in high school, I made a mistake. I kind of thought that if I inverted, I could use a left-hand rule. Don't ever try to use left. There's no left-hand rule here. Just right-hand rule every single time. And this you're going to see all over the place in electromagnetism. A lot of fingers curling. If you point your thumb in the direction of the current, the magnetic field is the direction of your fingers curl, and vice versa. Very good stuff. So get used to the right-hand rule. Applications all over the place. And I think this is going to come in very handy when we go through our examples, because we're going to be doing torque, and first we'll do a general example of just cross products, and then we'll do a little torque, maybe a little E&M, EMAG, electromagnetics. Maybe we'll dive in that deep. We'll see how it goes. But so that is the right-hand rule. And next week we're going to do a generalized cross-product example with just a couple of numbers in 2D and 3D, and we'll take it from there. So we are knee-deep in vectors, and we got a beautiful 61% illumination moon up in the sky. I think that's going to do it for this week. But first, I try not to pander too much to the old physics crowd, but if you want to support the show, check out the apps in the App Store. We got like 40 apps up in there. Always, if you go to the blog, pwnyouRhw.blogspot.com, there'll be a little for every episode entry available in the App Store. You can click that. It'll take you to the full app list. We got kinematics, we got force, we got calculus, we got trigonometry, we got components, we got units of measure, we got powers of 10. It all helps. And I think that, support the podcast and support yourself in a way. It's always a good review, and it'll keep you mentally fresh and in the zone. So if you're feeling generous, if you're feeling like you want to treat yourself to an app or two or three, go for it. Or check out the physics brush up bundle if you're still in brush up mode. I think that brush up bundle is great before you're going to take your first, second, or third, or even final exam. Make sure you get the fundamentals in place before you start worrying about everything else. So there we go. What is that called? Shameless self-promotion? Anyways, check it out. They're great apps. I think you're going to love them. And I do appreciate that everybody tunes in and listens to the podcast at the very least. I hope that you take something positive away from it every week. So I think that is going to do it for the week. So until next time, guys, stay frosty, stay in the zone, and we'll catch you next time. Take care.